So there's an equation to relate the half-life to the amount of materials, and it's this equation on the screen. And the truth is, most of these variables you've never seen before. So I gotta run through them. A is the amount of substance left. Left is really important here. A sub naught, or A0, is your original amount. That's your starting amount. Okay? And then it's 1/2 small t, which is the amount of time that's gone by. And then big T, which is the half-life. And the one thing about small t and big T is to make sure you're in the same unit. So if your half-life is measured in seconds and you try to do your elapsed time in minutes, it's not going to work out for you. So here's an example problem. Iodine 131 has a half-life of 8 days. Gosh, how many grams would be remaining of an 80-gram original sample after 3 weeks? So our original amount is this 80 grams. We're looking for how much will be remaining, so we're looking for A. Your half-life, right, given to you is 8 days. And your amount of time elapsed has been 3 weeks. 3 weeks and 8 days are not in the same unit of measurement, so we got to make that 3 weeks into days. 3 times 7 is 21 days, so we'd have 21 days divided by your 8-day as your superscript up here. So there it is, all filled out. If you calculate that, then you'll find you have 13 grams left. So this equation is really great in calculating amount of stuff left over or the amount of stuff you originated with, but it's really hard to calculate a half-life from this equation. Now, this is an example problem where if you were going to calculate half-life, it's tricky. What I have for you is a rearranged equation. And since you're doing this test online, you can actually just use these equations. You just need to know how to use them. This equation is not a different equation than the one on the other screen. It's just a rearrangement using logs, which is something that's challenging for a lot of people. So this equation can be used instead. Same variables. Big T is your half-life, small t is the amount of time it's gone by. A sub naught is the stuff you started with. A is then what you finished with. So if you're going to plug in the numbers from this problem right here, the amount of time that's gone by is 600 seconds, right? Ln of 2 was just calculated to be 0.693. A sub naught, your original amount, is 500, and then you eventually have only 16.63. So if you calculate that, you'll get a half-life of about 122.2. We're going to do more examples with these problems tomorrow and actually do a lab on them tomorrow. But the form will ask you to do a little bit of calculating with this too for me to see if you can manipulate these equations. Okay, have a nice night. I'll see you guys tomorrow.